In part 2, we will be looking at random samples. And a random sample, I wrote up here, is when each member of the population, remember population is the entire group that's being surveyed, has an equal chance of being selected. So we're going to end up using this idea here about a factory produces 5,000 car parts each day. We're going to use this for these two different problems. It talks about a manager at a factory estimates that no more than 135 defective parts are produced each day. Well, how can we prove his claim is right? He's just saying this. Well, that's what they ended up doing here. They took a random sample. And a random sample means that, again, each member of that population had an equal chance of being selected. So a random sample is always good. And we found that 50 parts, out of 50 parts, that was the amount that was sampled, show that 2 are defective. So let's find out the percentage from this sample, this random sample. So what we're going to do is we're going to take the 2, and we're going to use this as our part. So this is our part, and we're going to find a percentage. So that's our part. The 50 is going to represent our whole. And so we're going to end up using a percentage, which is just a part over a whole. And so we're going to go ahead and do a division problem, reduce this fraction. So we have 2 parts out of 50 total that we ended up sampling, and which would reduce down to 1 over 25. From there, we need to figure out what is this a percent of. And so what's the percentage of this? Well, let's just do this. Let's divide 25 into 1. Well, it's not going to go there, so we're going to add a decimal point. And 25 doesn't go into 10 either, so I have to add a 0. Add another 0 here as I did. 25 into 100 goes 4 times evenly. So there it is. We did the subtraction, we got 0. And so this is the same as 4%. Well, that's the actual number of defective parts that we have. 4% of the parts they produce are defective. So let's see if his theory is right. About 135 parts out of the 5,000 are defective. So what we're going to do is find out actually how many are going to be defective. So we're going to use this 5,000 up here, and I'm going to multiply it by the percent. I want to know 5,000%, or 5,000, and I'm going to multiply it by the percent, 4%. But remember what we do when we're dealing with a percent, we got to change this to the decimal form. So I'm going to use this 0.04 and then multiply it by the 5,000. And so when I do this, I just do 5 times by 4, and that gives me 20. And then I bring down all these zeros, so 1, 2, 3 zeros. But then I have to move the decimal back 1, 2 spaces. See how there's 2 spaces there? So that moves it back right there. So the number I get is 200. And so he says that there's 135 parts. I would say no. No, it is closer to 200 parts. It's closer to 200 parts that will be defective. So I think he's a little bit low. If he was at 195, I'd say, yeah, it's pretty close. But being a little bit further away, being 65 off, I would say no. I would bring that amount up. He's kind of saying that his product's doing a little bit better than it actually is. Obviously, the manager doesn't want as many defective parts, and he's stating something that seems a little bit low. Well, in this next problem, it says the factory owner this time claims that approximately 600 of the car parts are labeled incorrectly each day. Well, that seems kind of high. Let's see what the random sample was. 75 parts. Out of 75 parts, it shows that 9 are incorrectly labeled. So let's do this. Let's do the same thing we had done before. We've got our part over our whole. So what's the part of the sample? That was incorrect. It was 9. Incorrectly labeled was 9. The total sample was 75. So I'm going to reduce the fraction just to make it a little bit easier on myself. So I'll divide by 3, and I end up with 3 over 25. Now, the last one was 1 over 25. 1 over 25 was 4%. So 3 over 25 is going to end up being 3 times by 4. And here's another way we could have done this rather than dividing. See, if you want to change it to a percent, we could end up making it a number over 100, because that's what a percent is a number over 100. And I see if I multiply this by 4, 25 times by 4 gives me 100. And on the top, 3 times 12 gives me 12. So this is the same as 12%. So 12% is my number. Now I'm going to go back to the original number of parts that's produced, the 5,000. I'm going to use that number. And I want to basically find, let's go ahead and rewrite this. I want to find 12% of 5,000. That's what I'm trying to do. I want to find out what that 12% of 5,000 is, because 12% of the parts are going to be incorrectly labeled. And so we want to find the amount that is and see if it's close to 600. And so what I'll do is I'm just going to take this 0.12, so I changed it to a decimal, and I'm going to multiply it by 5,000. I'm going to do the same thing I did before. So I'm going to do 12 times 5, because I remember that is 60, and I'm going to bring down these two zeros. These two zeros just get brought down, and then I move that decimal over 1, 2 spaces. So 1, 2 spaces makes 60. And let's see here. And oops, I see my error here. See, I did 500, but what number was that supposed to be? It's supposed to be 5,000. So let's add that extra zero there. And let's fix this decimal point. So I'll go ahead and add that zero back in there. Bring this, and then I move it over 2 spaces. So there we go, 600. So sometimes you might make an error like I did there. And so if you look at your answer and you say, 60, that seemed kind of low. This guy had 600. So let me make sure I was doing the problem right, and I saw I had written something down incorrectly. So let that be a lesson. Make sure you always go back and think about your answer. Think about if it makes sense. It didn't match the factory's owners very well, so I went back and looked to see if I had made a mistake. And I had, and so I went ahead and fixed that, and I got the same as the factory's owner. I got 600, and that kind of makes sense. 12% of 5,000, yeah, that'd be about 600, and so there we have it. So in this case, I would say yes, and based on the random sample, random sample. And again, we're basing our conclusion on that random sample because we're using its percent. See, we use that 12%. So we're basing it on the random sample. Based on the random sample, you can predict that 600 of the 5,000 parts will be incorrectly labeled. So there we have it. So the key on these is to remember to find that percentage. And you're going to use the decimal form of the percentage afterwards, and then you're going to multiply that by the total number to see if it ends up matching what the manager ended up saying. So those are some problems that you'll end up seeing on tonight's homework. Good luck.